Welcome to 200 Level Go. Today, our goal is to get our tiny web service talking round trip with DynamoDB. We're going to need DynamoDB to be our backend for our service. That's how we plan on tracking our users who have signed up and paid for the service so we can do the things we need to do, like make sure they can see the private videos. So today's goal is get our little web service talking to local DynamoDB through the local Docker container they provide. We're going to make a new endpoint that will put something into the database and show we have complete round trip communication. Let's get to it. The first thing that we're going to do is install the Go SDK into our project. So to do that, we need to use uh, Go mod, which is the current best way of doing Golang dependencies. So we're going to do a Go mod init. Right, so that's set up. And we can now run go get to find our dependencies. And we want the AWS SDK for Go. And that's going to be, we're going to do go get github.com, AWS SDK Go, and we want to do a specific version. I'm looking at the page now, and the most recent tag is the 136.23. Right. So now we have that as part of our project. We can actually start using the AWS SDK for Go. So the first thing we're going to do is, for our testing purposes, we want to be able to make sure our table is there. Because with our Docker container for DynamoDB, it's going to be standing up and shut down, stand up, shut down. We want to make sure that our table is there before we try interacting with it. We'll make a setup table function and we'll call that in main. And normally, if you read the AWS SDK docs, they tell you to make your service client dynamodb.new and make a new session like so. This will let it talk to the real DynamoDBs, but what we want to do is override this session with pointing it at our local host, which is where our Docker container is going to be running. So let's add an argument of new config. Our endpoint is where this Docker container is going to run. So on this machine, it's HTTP localhost, port 8000. And we want to also configure with region US East 1. That'll be kind of overridden by the endpoint configuration, but I'll let it be configured correctly. And we want to make a new table. And AWS SDKs generally have the pattern where you have your service and then you give it an input to an action on it. In this case, we're going to make that input. So a table create input. It's going to be DynamoDB. This table's input. And so actually what I want to do first is list the tables that are there. If we don't have the table that we want, then we create it. If it's there, we don't need to do anything. So list tables request. Oops, this table's input. So by default, this is going to give us all the tables that we have access to in that region. Now we're going to call the DynamoDB service and call list tables. Handed our list tables request. And then we handle any errors. In this case, we just want to print the error and then keep on going. Do the simplest thing first here. So we do get results. Let's print those out. And let's look for the table that we want, and if it's not there, we'll just create it. Our table name is going to be 200 LG users. So we'll loop through our table names that we found. If we found it, it's there. Sweet, nothing to do. If it's not there, we need to create it. If we found it, say it's true, and we'll stop iterating because, well, we don't need to anymore. If we didn't find it, we're going to do something similar where we're going to make our request object and pass it into our DynamoDB service. This is going to be a table creation request. So create table request. Create table input. This one's going to take a little bit because the minimum that you need to pass it is 4 or 5 different configurations. Of course, the most important one for us right now is the table name. And AWS handles things a little differently than most other libraries. So we need to kind of wrap most of our things with this helper function of AWS string. So we're going to wrap our table name with AWS string. We also need to provide the provisioned throughput, which is a requirement we'll make in tables. In our case, we're going to set it to read and write of 5. That'll be just fine. We can adjust it later. So another one of those helper functions. And give it 5. And write capacity same. We need our key schema, so that'll tell DynamoDB how to partition our data, what to use as the primary key, kind of. And to do that, we're going to make our key schema. It's going to be a slice of references to DynamoDB key schema elements. Our first one, attribute name, is going to be user ID. And our key type is going to be a hash. Now we need to make our attribute definition, so attributes on each row in our table. In this case, we're going to store the user ID as a string. So attribute definitions. It's going to be a slice of references to attribute definitions. Our name can be the user ID. And the attribute type, we're going to make this a string. Which they represent with an S. Make sure we got all of our commas. And now we got our create table request, and we're going to send that off and see if it works. So our DynamoDB service, I'll create table, and we're going to pass in our create table request. Log out if we get an error. Otherwise, say everything went fine. And this is saying we need to pass it a reference instead of the actual item. So there we go. And now we've got our setup table where it'll list the tables at first. If our table isn't in there, it will create it for us. So this should fail if we try running it now. So let's head over to the terminal and verify that. Now, this is going to take a little bit because it must try to contact localhost, which has nothing running on that port, wait for it to time out, and then it'll give up and report the error. Well, in the meantime, we can look up our Docker container we're going to use. The AWS documentation for local DynamoDB has a variety of options you can use to run local DynamoDB. In this case, we're going to run Docker because, well, that's handy and I'm used to using it, so we're going to run that locally and have port 8000 available to our computer so that we can have this run and it'll work. So time out soon. And while we're waiting for that, let's get this ready for being able to run that Docker container. Docker run. We're going to put it in the background with -d, and our port, we're going to have port 8000 available to our host machine. We're going to run Amazon DynamoDB local. And we can see that our send request failed. So there we go. We know it was trying to connect. And now let's run our Docker container, see it connect, and it'll verify that we're having correct communication with DynamoDB. Okay, now we can see it's running. That way, when we go back to our terminal, it should be a whole lot faster. We do go run. So now we can see, didn't find any tables, so it created a new one. So we've got our communication with DynamoDB working, and now it's time to move on to being able to actually put something in there and pull it back out. To make things faster for our demonstration, we're going to put the retrieving it into our hello handler. So that'll try to pull something from or pull all of the users that are in the users table, and not all of them. It'll pull a certain one. So we're going to have it try to pull a specific user out, and then we're going to set up a new endpoint that puts that user in. That way we can demonstrate a round trip test where it can put something in there and retrieve it back out. So to make this a little simpler, we're going to create a new DynamoDB client similar to how we did above. And for this, we're going to do a get item. So our get item request, DynamoDB get item input. We need to give it our table name and the key that we want to pick up out of it. Our table name is 200 LG users. Our key, this is going to be a map of strings to DynamoDB attribute values. A little bit of a mouthful, but once you see it, it'll be a little more clear on how this works. We're searching for a string that matches user 00001. Now that we have this request, let's try getting our results. We'll get our item request. If it worked, or if it didn't work, let's print out what happened. Otherwise, we'll handle our success case. Because something else that could happen is the number of items retrieved is 0, in which case we need to make sure we handle that. The thing we wanted wasn't there. Otherwise, we'll print out what user we got. Right now, this isn't returning it into the HTTP request. We're just logging out that we have it to make this video a little bit shorter in terms of what we can get done in the time that we have. So DynamoDB is still running. Let's give this a try. So our hello handler, when we run, is going to be available at localhost port 3030/hello. So if we bring open our terminal here, we run. Yes, still out in the network. Our table is there. Let's try this. We expect this to say that we could connect to the service, local DynamoDB, but our item list was empty because there are no items in there right now. Let's see if that worked. In our logs, it says item wasn't there, which matches what we expected because no item matched that key at the moment. Let's work on putting something in there. For this, we're going to make another handler. So insert handler. It's going to take the same signature. And we are also going to write out something to the caller so they know what happened. And I'm just going to say we inserted something. We want to register this So if we do slash store it, it'll insert it in there. This is going to work similarly where we're going to make our client. We're going to create our request for inserting something into the table, which is going to be more like an upsert. And once we have that, we can restart or we can show that our get finds no item there. We'll call this insert endpoint, and then we'll see that it is there on the other call. So insert item request, the DynamoDB put item input. We're going to tell it what table name that we want. Again, this is 200 level Go users. And our item, which is a map of strings to DynamoDB attribute values again. Where the user ID is a string of this user, same user here. So in fact, grab that, put it there, and our put item request is done. Let's go use it. I'll put item. We're going to give it our request. Log out if we had a problem. Otherwise, everything went swimmingly well, and we'll print out what we inserted. Let's make sure this works. So before, when we curled our hello handler, we saw in the logs that the item wasn't there, and we see that again. So if now we curl our new one of store it, that will insert something into our DynamoDB table, and we should see successfully stored the item. Now what we want to see is in the logs here, when we call hello again, it should find that item. And it says, we got this user. That's the one that we put in there before. We inserted it with this user ID as a string key, and then we pulled it back out from there. So we've successfully demonstrated round trip talk to DynamoDB. Now that we've successfully demonstrated that, we are set up for being able to flesh out what we want to store and adjust some of our attribute definitions in our table so we can store the information that we need, be able to adjust it as needed, and do as much testing with the local DynamoDB instance because, well, it's completely free to use. And then once we have some more data on how we want to do that, how we want to store the information, we can deploy this and start using a real one. So that's now for it. Thanks for joining. Make sure to check us out. We're on YouTube. We're on Twitter. We've got 200levelgo.com. And we are also on Patreon if you want to support us making more of these videos. Thanks. Keep on coding.